Hi guys, welcome to Learn Electronics Repair, and I have Olly with me today.
Hi guys.
Olly is one of the traders on the flea market where you see I buy a lot of my items, my flea market booty, car booty. And I saw him on Sunday, so he had this. He said, Rich, take a look at this. Olly, tell us the story.
Yeah, I saw on Sunday in the morning, I walk around the flea market, so I look at stuff, and I saw the 3 vents and run and said, what's going on with this graphics card? And he said, oh, it's okay, it's working and no problem. And I said, what do you want? And he said, $50. And I said, okay, I give you 20, and I test it the week, and on next Sunday, I pay the rest, or I give you back the card.
Okay.
And half an hour later, he ran to my place and said, oh, the guy from the card said it's not working. And then Richard is coming, and I say, Richard, I have a nice graphics card. What shall I do? It's not working. And he said, don't put it in your computer.
Correct.
Or you so I put it in my Threadripper, and I kill my Threadripper. Oh, very nice.
Yeah.
So now I'm sitting here with my nice new t-shirt on.
Very nice, yeah.
And let's have a look.
Yeah, sure. So you paid the guy €20.
Yeah, and if it's
working,
I give him 20. I give him 20 more.
Oh, I see.
Because
it
was
because of the trouble. That means I can charge him 10. So let's see. So we have a Gigabyte GVN 3060. So this is an RTX 3060 GeForce RTX, and I'm just going to show Olly what we need to do. So before we even plug this in, we need to make a few checks, and the first one is whether there's any short circuits, because if you connect this to your computer and there's a short on here, you will probably blow the power supply. You're unlikely, depending where the short is, you're unlikely to blow the motherboard. But basically, this has 3 power connections. Okay?
Yeah.
So one is here.
Yeah.
That's the big 12 volts.
Yeah.
That's the main current. And on here, on the PCIe, is another 12 volts.
Oh, yeah.
And a 3.3. So if you're unlucky and there's a short down here and you plug it into the PCIe slot,
it's not so good.
It's not such a good thing. So let's just check. This is the first thing. And we just need to get the meter where we can see it. So I have my multimeter on continuity.
Yeah.
If we connect these, Olly, we can, it bleeps,
Now it's Olly, now not.
Yeah, exactly. So it goes to 0 and bleeps. So the first thing we need to do is look to see if we have any short circuits in this connector. Now these 8 pins, 6 or 8 of them will connect to ground anyway, and ground is the metal work on the card, or should be. So let's have a look to see what we have. So I should see on some of these pins it should go to 0. Because you know yourself, on this cable there's black and yellow, and the black ones are ground. So I need to get a good ground connection onto the card. I don't have one at the moment. Let's go on to the HDMI connector, and we'll try again. Right, so that's one of the ground.
Yeah.
So we know we have a good ground.
Good,
okay?
good.
And the rest are reading open, basically. There's the ground, yeah? So this side is the ground. Yeah, this is all ground. Probably 6 of them. The other one's probably a sense. So anyway, there's no short.
Okay.
From this side, okay?
That's the first.
That's the first. Right, the second one is down here. So, again from the ground, on this connector, if you look, can you see these PCB tracks here?
Yeah.
So the first 3 fingers are all connected together. That's your 12 volts.
Okay.
So we need to measure from there to ground. And it's reading open. So there's no short from there. The 4th one, that's ground, by the way. That's why it's bleeping.
Okay.
And the 3.3 is 1, 2, 3, 4 in from this end.
Okay.
And that's okay. So there's no shorts on that.
Okay, that's nice.
That's the first nice thing. Now, the second thing, if you look on your graphics card here, you'll see all these tracks Can you see like
Yeah, I see.
Yeah, these are pairs. So each one, look, you can probably see it goes to 2 fingers. So these are your PCIe lanes. And there's 16 of them going up into the GPU. These all go into the GPU chip itself. In fact, if you look down in the gap here, between the fan, can you see the same tracks are there?
Yeah.
Heading up into the GPU, okay?
Go to the GPU.
Go to the GPU. Now, one of the problems we get with graphics cards, very common, is people connect a mining adapter.
Yeah.
And sometimes they connect the mining adapter the wrong way round.
Oh.
Into the PCI slot. And if you do that, you put the 3.3 volts directly into the first track here. Let me show you a mining adapter, you'll see what I mean. Okay? So,
you think somebody used it as a mining card?
if somebody used this as a mining card, because we don't know,
No, we don't know.
if somebody used this as a mining card and they connected this the wrong way round, it will destroy the card. So this is the slot,
Yeah.
and you'll see this only has a small board here. Yeah, we'll see that bit.
Yeah.
Okay. And we know, we were just discussing, on here we have 12 volts and 3.3.
Yeah.
And then this is the first of the PCI lanes, the first one.
Yeah.
Here. And that's how this connector should be.
Yeah. Yeah.
But if you plug this in back to front,
Yeah, this is bullshit.
the graphics card will think it's bullshit.
Yeah.
So what it will do is it will destroy the first PCI lane. Okay, and we need to test to see if that's happened. And the way to do this, on the meter, we go into diode test. Okay. And I'll show you what it does. So I need to get to ground again. I need to get to ground again. Okay. And we need to look at the first PCIe lane. And the first one, I don't know if you can see it, the reflection of it, it's actually here.
Okay.
Can you see there's one there, one there, one there. The first one is on pins 3 and 4. And we need to check to ground. They shouldn't read short. And they shouldn't read open. So that's reading about 1.6, yeah?
Yeah.
That one is ground, that's why it's bleeping.
Yeah.
That's reading about 1.6. I can't say what it should read, but this one and this one should read the same. Okay? And they should read the same as the other lanes. Like there's another lane here.
Yeah.
1.6. 1.6. So the fact they read the same, we can just go to another one.
Yeah.
1.6, yeah.
Also.
Now on a different model, they might read like 800 and something. But as long as they all read the same as each other,
yeah.
So we know that's not been destroyed. And then the same on the other side. So on this side, again, you can see all these lanes coming in.
And why is the first one shorter?
The first one is shorter because this signal tells the computer that the card is inserted. So it makes all the connections first, and when you push it in, that's the last one to make.
Yeah, if you have it not right inside, it don't make contact.
Yeah. So when you push in, you can make all the connections, and the last thing that connects is that.
Okay.
So once you've made these connections, straight away there's some power in here, and then it can send a signal. But you don't want that signal to go into the computer before it's fully inserted. So that's why it's shorter. So again, we need to check. So on the first lane on this side, which we can see is pins 2 and 3. It's not 3 and 4. It's 2 and 3. Can you see them coming down?
Yeah, it coming down here.
Okay. So again, now this will probably read different to the other side because this is the clock. This is not data. This is the clock. But again, it shouldn't read short. So it's reading 800 and something.
Yeah.
And that should read the same. 800 and something.
Yeah.
Oh, and by the way, the two should not be shorted to each other. And they're not.
Okay.
So this has not been inserted backwards with an adapter. Otherwise, you would either find that they read 0 or they read open. There's no
So
reading.
in the moment we have no shorts.
We can
test it.
We can test it. And not only do we have no shorts, but we know that at least the first PCIe lane is okay and that the clock is okay.
Yeah.
And we're going to test it with this adapter. So we're going to test this initially in single lane mode.
Okay.
See if it works.
You are the guy who knows the stuff.
Well, actually, I'm showing you. They're fairly simple test.
Yeah, this is cool.
And with a multimeter, anybody could test that. And probably 50% of all faulty graphics cards will either have a short on the 5 or the 3.3 or the 12, or these lanes will be destroyed. So straight away, that's like found half of the problem.
Yeah.
Yeah. So it's actually something that's fairly easy
So we have
to learn.
only the half of problems.
Yeah, we only have the half. I mean, those half of the problems, if you have a short here or a fault here, you can't repair that. It's the GPU. If we have a short on here, or the 12 volts to the 3.3, maybe we can fix it. It depends what's gone short and what damage it's done.
Yeah.
So we know we can plug this in. So let's power this up and see what it does. Okay, so I've connected your graphics card up. I have the 8-way connector. This is the mining adapter. This is what I was discussing about. If you plug these things in the wrong way round, you will destroy the graphics card.
Shortcut.
You actually connect the power supply voltage to the GPU directly.
Yeah.
And although it's only 3.3, the GPU runs on about 1 volt or 0.9 or the 3.3 is like much.
It's a lot.
It's a lot, yeah. So it just dies. So we have the analyzer card in. Now, this will count up during the boot because I don't have any connected right now. But when it finds the graphics card, it should come up with a code like 2D.
Yeah.
Or something like that.
And beeps.
And this you go, beep, 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 beep. Or blip. So one blip means it's found it, the beep, 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 and it hasn't, and this will give us a code as well if it doesn't find it.
Oh.
So if this stops when we get to 2B or 2D, it's not seeing the graphics card. Okay?
Okay.
So we can switch this on, and we can try. Well, that's booting.
Yeah.
One blip. So it's finding the graphics card. It's found it. So we're getting further. Now we'll connect the graphics card to the monitor.
To the monitor, yeah.
So let's see if we get a picture on there. So we'll power on.
And now I cross my fingers.
Yep, start.
Cross my fingers.
It's booting up.
Yeah, it makes a beep.
But it doesn't give a picture.
Yeah. Nothing.
Nothing. That's interesting. Sometimes, just sometimes, this capture card doesn't work very well.
Okay.
And what I can do is plug your graphics card directly into my other monitor. So I've connected to my other monitor, which we can see there.
Okay.
We'll set this to DVI. So I've connected into a DVI adapter.
Yeah. And
we'll try it again. So power on, start.
DVI no signal. No.
One bleep.
One bleep.
Okay. It may be that the bleep we're hearing is actually not detecting this card. It could just be detecting the onboard graphics, maybe if it's not seeing this at all. Because this has onboard VGA. So let's see if we have a picture on the onboard.
Okay.
VGA. Yeah. So now I have a picture that's on VGA.
Yeah. And here
I can show the good people out there what's happening. Okay, so the good people out there can see that I actually have a message. I have no hard drive on this at the moment. But that is with the VGA, so that's still on the onboard.
Yeah.
If we go to DVI, which is what's connected to the graphics card, we have nothing. Okay? Nothing. So what's happening is the computer's actually not seeing this at all.
Yeah.
It's just seeing the
onboard. Yeah.
So we need to have a look to see whether or not, if we try Linux, can it detect the graphics card? If it can't detect the graphics card, then I would suggest we need to measure some voltages on this as well. But let's see if it can see it in Linux. Okay, Ollie, so as is typical when you're making video, you can't find the Linux boot stick. But what we didn't think to do, or I didn't think to do, was see if the fans are spinning when I power it up. So let's just switch it on again. And the fans don't spin. Okay, so this is not powering up, I would say. So let's check the voltages on here. So here is the graphics card. I've taken the heatsink off. So we know we have 12 volt connection, 12 volt and 3.3 coming in. We know there's no shorts on them. Now, nothing in here runs on 12 volts. Some of the circuitry runs on 3.3. So there are what called buck converters in here, the DC to DC converters. So you take the 12 volts and drop it to lower voltages. And normally on a graphics card, we'll find a 1.8 volt supply, which is probably for the BIOS chip. So the BIOS chip, which will be that one, almost certainly, will either run on 3.3 or 1.8. With a modern card like this, it will run on 1.8. So one of these converters will take the 3.3 and make a 1.8.
Yeah.
We also have a 5-volt supply, which is generated from the 12. We have VRAM, that's the voltage for the RAM chips.
Okay.
And that'll be, where you see these big blocks, these are little coils. So VRAM will come from one of these. We'll have VCore, that's the voltage for the GPU. This is the GPU chip.
Yeah.
And that will come from here.
Yeah.
Just because there's a whole batch of them together. I know that these 6 will be making the VCore. The reason there's 6 is because the VCore draws the most power. So one of these converters isn't enough, it uses 6 of them.
Yeah.
And on a big card, it uses 12.
Oh.
You know, on something like a 3090 Ti or something. So 6. And then we'll have a supply called PEX, which is PCI Express, PCIe. Yeah. And that's the circuitry which communicates between the motherboard and here. And that's 0.9 volts. So we should have 5, 3.3, 1.8, 0.9. VRAM is probably about 1.2, depends on the type of RAM.
Yeah.
And the VCore maybe 0.8. So let's see what voltage we have on your card. Okay, so we're ready to go. Now, the first thing I want to know is the VCore there?
Yeah.
Because if the VCore is there, this GPU will get very hot.
Okay.
And the easiest way to test, one is to measure VCore over here, and the other one is to put your finger on the GPU.
Yeah.
If the GPU gets hot, I'm going to switch it off. And if it gets hot, I know I have VCore. So let's power it up. And it's cold.
Okay.
That tells us 2 things, well, 3 things. First, we don't have any VCore. There's no voltage to the GPU.
Yeah.
Secondly, it's not going to get hot, so we don't need the heatsink on.
Yeah.
And thirdly, my finger survived.
Okay.
Okay. So let's see what we do have.
This is the reason why it not smells.
Yeah, it not smells it. I mean, although we have power coming in, unless there's a fuse blown, there's some fuses on here, we don't have any of the lower voltages. Now, you might think when you power a graphics card up, that kind of like all the voltages just all appear and it boots up. It doesn't. It has what's called a boot sequence or power on sequence. So the voltages come on and turn.
Yeah.
And as one voltage comes on, that part of the circuitry sends a power good to enable the next one. So normally you'll find first you put the 12 in.
Yeah.
Then you get the 5.
Yeah.
3.3 is already there as well because it's from here. Then you get the 1.8 comes on. Then after that, depending on the card, the PEX will come on 0.9. Then the VRAM and the VCore.
Okay.
Or VCore and VRAM. And it depends whether it's Radeon or NVIDIA as well. So let's see what we have. So although I don't know where the voltages are going to be exactly, I'm just going to see what I can see.
Okay.
Okay. And see what I can find. So that clearly has nothing on it. There's nothing there. Do I see the 12 volts? Yeah, there's the 12 volts. That'll come into here. Yeah?
Yeah.
That big one. These will probably be the VRAM. There's nothing on those ones. VRAM. Here's VCore. There's nothing on VCore. What's on here?
There's Olly.
That's your 5.
Okay.
So I said that after the 12 comes the 5. So the 5 is there. 3.3 is going to be here somewhere. I need to just make sure I have a 3.3. That's 5. So VCore is nothing. Where's the 3.3? So just trying to find out where that comes in. At the moment I don't see the 3.3. I'm basically just poking around just to see if I can if I can find it. 3.3. Okay, nothing there. There's another one up here. And I haven't found the 1.8 either.
Yeah.
So it looks to me like this is failing early on in the sequence.
Yeah.
So after 12 and 3.3 we should get 1.8 and this should come in sequence, and I can't even find the 1.8, so it's not getting very far. And it could be that the 3.3 is missing. Let's see where that comes in. So I know it comes in on the 4th finger down here. I should see it on here.
Yeah.
On the adapter, just to make sure we're not cracking up here. So just get ground. Probably on here somewhere. Yeah.
Yeah.
There's the 3.3
Yeah.
on the adapter, so it's,
Yeah.
it's getting as far as there. Where's it on the board? 1, 2, 3. It's going to be here somewhere if it's on. Oh, that's a fuse. See
Yeah.
that F3?
Yeah, F3.
That is a fuse. What's on that? It should have some voltage on it. 5. And the other end, 5.
5.
So the fuse is okay.
It's okay, yeah.
Yeah.
And this card have more fuses or only this one?
It will probably have another fuse up here near the 12 volt.
Yeah, there's one.
Well, that's not actually a fuse. That's a low value resistor. But quite often they use them kind of as a fuse as well. But the 12 volt comes in and then goes through onto this thing.
Yeah.
Okay. And the fact I'm seeing 12 volts there tells me if there is a fuse, it's okay. The fuse would be before that.
Yeah.
Between here and
so
here.
we have 12 and 5, and have no.
Yeah, and the 5 is generated from the 12, but I don't see the 3.3. I think I'm gonna have to take the metal plate off the other side and have it to see where that actually is. I mean, the 3.3 is just coming in, so it should.
Yeah.
It shouldn't really go missing, you know. I mean, it's not generated by the card;
Yeah.
it's incoming, so it shouldn't really. That's probably why I can't see it on one of these coils. Let me just have a quick look. There's some capacitors down here. Do I see a 3.3 on the card? If I just see it somewhere.
3 point. At first 3 point, and now it's gone.
No, 3.3 is on the mining adapter.
Yeah.
So we know 3.3 is on here.
Yeah.
But I'm so far yet to find it anywhere on the card. And we know that's the 5 volt fuse. So
Yeah.
I'm just looking to see if I can see it. Oh, I know where I'll find the 3.3. Possibly. On the BIOS chip, it may be a 1.8 or a 3.3. That'll be here. Pin 8. So the BIOS has no power.
Uh-huh.
I'll tell you what, let me have a look to see if I have a schematic for this.
Yeah, no problem.
Yeah, let's have a look. So it's a GV. And this is how I tend to work. I kind of like tend to jump from one thing to another as I'm going down the route.
Yeah.
It's like not a path, it's like a many forks. And as I come to one point where maybe I don't see how to move forward, I'll just switch to a different path. So although sometimes it seems like I'm a bit random, I'm actually just thinking, okay, what can I do next? And the next thing is probably to see if I have a schematic. So GV N360 Vision. Let's have a look. Okay, Ollie, I have a schematic.
Okay.
This is a schematic for your graphics card.
This is nice.
Yeah, so this tells us, this is a circuit diagram. This, for example, will show us where the 3.3 is and where all the voltages come from. Now, I need to sit and go through, so I'll put this on to, I'll probably just extend this video after you've gone, and I'll just go through this and try and work out why it's not powering up.
Okay.
So there's a good chance that the GPU, the RAM and such like are okay. It just isn't getting that far. Because obviously at the moment there's no power on them, so they can't be doing anything. But there is something else we can check, and we'll just do that now to get another idea
Yeah.
what condition the graphics card is in. So, well, look here, look, as I'm going through, 1.8 volt switcher.
Yeah.
So this is part of the 1.8 volt circuitry. And from that I can find out which chip it is and then see what it's doing. Okay, so there's one more thing we can test just now. And this will give me another good idea if your graphics card is any good. So what I'm going to do is measure the resistance on all these voltage supplies.
Okay.
I don't know exactly what this should be, but if I find shorts on any of them, I know we've got a faulty GPU.
Okay.
So this GPU I mentioned has about a 0.8 volt supply. Well, in actual fact, the GPU talks to things.
Yeah.
So it talks to the BIOS.
Yeah.
So whatever voltage the BIOS is, say 1.8, part of the GPU must also have 1.8.
Okay, yeah.
Because it talks to the PCIe.
Yeah.
You can see those lanes coming in. This runs on 0.9 of a volt, this PEX.
Yeah.
So the GPU will have a 0.9 volt supply.
Yeah.
It talks to the RAM.
Yeah.
So again, whatever voltage the RAM is on, it will have a voltage supply the same.
Yeah.
So this will have VRAM, VCore for itself, VPEX, voltage for the BIOS, and it will probably have another voltage which is called memory controller. So inside here is a memory controller, and that will also have a voltage very similar to VRAM, VMEM control. So these various coils will generate all these voltages. And I'm going to look at the resistance on them, and I'm going to tell you what I think, okay? So first of all, VCore. Now this will read very low. This could look almost like a short. So we go to resistance. And this we would expect to read maybe 0.2 of an ohm, 0.3 of an ohm, something very low. Now it's saying 0.8. But if I short my leads together, it's saying 0.5. So that is about 0.3. 0.1, 0.2, 0.3. That is very low anyway. That's normal for a high-end graphics card.
Okay.
The other should be quite a bit higher. So one of these two will probably be VRAM, and one will probably be VCore. So that means 36, 37. Could well be the memory controller. Sorry, this is VCore. That could be the memory controller. If this is RAM, expect 80, 90, maybe. 36, 37. But it's not short.
Yeah.
PEX is going to be, usually it's one of the ones down here, near the PCI. That one reads just open.
Okay.
450, so that's not short.
Okay.
There's one up here, this could be PEX. PEX is normally about 50, 40, 12, okay. Again, that's not short.
Okay.
So I would say that there's no shorts on your card.
Okay.
Those resistances, although I don't know this card, they look reasonable to me. I think it's probably voltage memory controller. This is probably PEX actually, the 12.
Yeah, yeah.
The one that's reading quite a lot higher is probably the 5 volt. In fact, I think we measured 5 volts here, didn't we?
Yeah.
That's quite normal. So all the resistances look okay as well. So I think it's very likely the problem with this graphics card is something in the power on sequence.
Yeah.
So basically the power on sequence is controlled by chips like that one. You see the one there?
Yeah.
That's next to that one. There'll be one on the other side of the board which controls all these.
Yeah.
There's another one there, which is probably the 5 volt. These are the controllers. See another one there?
Yeah.
That'll be controlling possibly both of these. And these controllers, they basically take 12 volts down to whatever you want.
Yeah.
And they have what's called enable and power good. So the way this would power up, basically, once the 5 volts is up, the 5 volt controller will send a signal. It's just one connection from there to the other controller. And when the power good on this goes to 0 volts or 3 volts, it depends on the card. Let's say 0 volts. So that power good will have on, say, 3 volts. And when this is okay, the 5 volts here, it'll put it to 0.
Yeah.
And the next chip in the sequence will see their enable go to 0 and say, okay, I start.
Yeah.
And once it's started and the voltage is there, it'll send its power good to 0.
Yeah.
And that connects to the next controller in the sequence. It'll say, okay, that's good and that's good. So now I'll enable. So each power good is connected to the enable.
Yeah.
It's like a chain of daisy.
Yeah.
And what's happening with this, I would say, it's failing somewhere early on the daisy chain. Which is probably because one of the voltage rails isn't sending the power good, even though it's okay, or the next chip is dead.
Yeah.
Or there's a break in the connection, so it never gets the signal enable to switch on. So that's what I need to do now, is using that schematic go for your card and check all the voltages and see what we have. Okay. So I'll let you go, Ollie. Thank you for your entertainment today.
It was nice and interesting.
Yeah.
And I hope my card can.
I would say it has a good chance.
Yeah, I think so, because I see nothing is burned, nothing is blowing up.
Nothing with short.
It's very new.
Yeah.
And
I don't find any fuses blown.
Yeah.
It's looking
I can
good.
see this here under the microscope. it looks very nice, and you don't have this little dust stuff and nothing on site.
Exactly. So we'll leave it with me, and I'll have
Yeah.
And I'd say you've got a better than 50% chance. I mean, until the thing's running, I can't say.
Yeah. Only the question is, can you
Do it this week.
Yeah.
I try.
Yeah.
I have 1 or 2 other jobs to do, but let's see if we can get this for you by the end of the week.
Because I have to say something on Sunday to this guy.
Okay, I'm sure I can give you a report to let you know what's wrong with it by then.
That's cool.
Okay.
So, guys, thank you for watching the video.
And hope you enjoyed Ollie's company today.
The old German idiot.
And I will continue with this. Okay, thanks for watching, guys. See you all soon. Ciao for
Bye.
now.